So modulus, let me just reintroduce it in the HR context pertaining to heading to what you learned before in AMF, okay? The modulus function, right, when we did AMF, right, it was just like, oh, whatever that's negative, just turn it positive, right? If it's 0 or positive, stay as it is. Now that you have actually covered functions in a more rigorous fashion, right, we can actually write this properly as a piecewise function. How does the computer or the GC learns this, right? It's actually reading it like as a function like this. This is actually equal to x or minus x if x is like this. Because mathematically, how does a computer turn a negative number into a positive one, right? It's to multiply it with negative 1. For example, if you give me minus 5, I will multiply it with negative 1 to turn it into 5. Okay? Otherwise, the absolute function or the modulus function doesn't have any physical meaning to a computer or a calculator. Okay? So if you read this function, right, it's like saying, if you give me a positive number or 0, I will just output you the status code like it is. Okay? Whereas if you give me a negative number, let's say negative 10, right, I will reply you with negative 10, which will return you 10. Okay? This is how the modulus function actually works. Do you actually need to know this in a rigorous sense? Not really. Okay?
Okay.
Okay, so modulus transformation, right, has got 2 kinds also. So the first kind is when it's applied on the output post exterior of f. So you can have this or you have this. Okay, so you can see that in both cases the modulus is applied post exterior of f, so on the output, which means that you are affecting the y values. So this is what you have been doing since secondary school days. That's easy. Anything that's below the x-axis just gets flipped upwards, isn't it?
Yeah.
Okay, so as a picture, let's just say if you have something like this point here is 2, negative 3. So this modulus is applied post exterior of f, so on the y values. So post transformation, you should see it as 2, 3. Agree? The x values do not get affected at all. So if you apply the same logic across all the points with negative y values, so you should get this, and this. Oops, pass through that point 2, 3. Okay?
Yeah.
So that's it. This is basically what you learned in secondary school. Okay. So if you look at this one, it has actually 2 transformations, right? The modulus first, followed by the negative sign. So you can actually see it has 2 separate transformations. And both transformations are applied on the output. In this case, post exterior of f. On the output means it's following the rules of algebra. So you actually have to do the modulus first, followed by the negative sign.
Okay, yeah.
Okay. That thing is just a...
Where does modulus fit into order of operations?
Okay. So it's just like following the basic rules of algebra right now. So because you know that this modulus is applied on the output, right? So it's following the rules of algebra. So let's just say today I give you this thing. Modulus negative 5 times 3 plus 2. If you need to evaluate these 3 things, I mean, if you need to evaluate the final answer, right? There are 3 operations here, right? The modulus times 3 plus 2. Which one do you do in order? Which order do you actually execute them then?
The order that you just wrote?
Yeah, so that is the order of, that is the rule of algebra then. Okay.
So modulus is kind of like brackets.
When it's applied on the output, yes.
Okay.
Okay. So if you see it has 2 transformations, which is my preferred method of thinking, right? You will have to do this, right? You have to take care of the modulus first, which is essentially what we covered this to flip everything that is down above. Then you flip the wholesale graph downwards again. Agree?
Yeah.
Otherwise, if you were to want to combine these 2 together, the end goal is just this, isn't it? Anything that was above has got to be flipped down right at the start.
Yeah.
Okay. So of course, some people will just simply look at it this way, right? In terms of thought process, just in case questions can get more convoluted than ever, right? Stick to something like this.
Okay.
Feel free to draw any preliminary graph along the way. like here first, and then here, and then has your ended marks anyway.
Yeah.
Okay, because we obviously do not expect you to be writing statements like this now in your presentation, right? But you can draw preliminary graphs along the way to illustrate your train of thoughts.
Oh, okay.
So these are all modulus on the output. That is easy to understand, right? Because you've been doing this in secondary school days. It's about affecting the y values. That's all. Okay?
Yeah.
And I mean, any transformations that's given to you, right? You should always ask yourself, who gets affected first and what gets affected. Okay? So if you look at these things, if you look at the pure modulus, right, is the negative y values that get affected, right? This guy, right, has got two transformations. The first transformation affects all the negative y value. The second transformation actually affects everybody. Hence, the whole graph gets flipped downwards. Okay, so this is how you interpret these kind of things.
Okay.
What's really difficult is when you have this. Okay, the modulus is applied only onto the x. Okay, so if you look at, okay, there is no mathematical way of writing this in a function rigorous way or whatsoever. So you just need to argue and sort out your train of thoughts on these things. So if you look at this, right, who gets affected in the graph? So if I just give you
x values.
Exactly. Okay. But how do they get affected now? So let's say if you have a graph that's like this. Okay.
Yeah.
Then who gets affected? So you are saying the negative x values get affected, right?
Yeah.
Okay. So this bunch of guys are affected. Okay. Okay. So the positive x values guys do not get affected, right?
Yeah.
Which means if they do not get affected, which means that the post transformation, they should still stay the same, right?
Yes.
So based on this original blue graph, the guys on the right hand side can just stay the same.
Yes.
Okay. Okay. And then what about the guys on the left then? How will they get affected?
It will be reflected in the y-axis.
Okay, which is why I just stuck down there.
Oh, you did? Okay.
But how did you came to this conclusion?
Isn't it obvious? I mean, like.
Whoa.
Wait, no, I mean, like, I don't understand what else you're supposed to do.
Like, how do you get rid? Then what should I do about this original blue graph on the left hand side? Does it just gets forgotten or something? Or
it just dies, yeah.
Why though?
Why not? I mean, you've like applied the transformation, right? So it's changed the graph, so it's not there anymore.
Okay, but will the guy on the right side gets cut and paste or gets copy and paste though?
It's like flipped, right?
When you say flip, right? So will the guy on the right hand side still maintain down there, or does it gets transferred on the left hand side? Is it a cut and paste or copy and paste? You get my question?
Yeah.
If you are saying it's cut and paste, that means the final answer is just like this, isn't it? So you are saying the final answer is just this arm only becoming like this?
No, wait, no. Okay, hold on.
So this is cut and paste, right? You are cutting the right hand side and then pasting on the left hand side, right? If it's copy and paste, then it will be like this, isn't it? You get my question first?
Yeah.
Yeah. So is it a case of cut and paste or copy and paste?
I don't know.
Yeah. So that's what I meant by the argument that you just had. So the guys on the right side do not get affected at all, right? That's what you said, right?
Yeah.
If they're not affected, so under this function, this expression, right, are the positive x values guys still well defined and can be calculated and everything?
Yes.
That means x is equal to 2, 3, 4, or 5 can still proceed as per normal, right? Which means that they are still intact, which means that hence they are still down there on the right side. Okay. So let's just say this point here is 2, 5.
Is it just like the entire left side of the graph disappears?
Yes, but would it be replaced with something else or what?
No, wait, no, yeah, because like if you input like f minus 2,
yes,
then it's the same as putting in f2. So it just it's just like double of the right side.
So that's why it's a copy and paste situation. It's not a cut and paste situation. Okay. So this point here is actually saying F2 is equal to 5, right? That's well established. It will still be well established when you are studying this. It's still equal to 5. Okay. But things get cranky if you wish to put -2, right? So if you say x is equal to -2, which means that you're actually trying to trace out the graph for the modular situation. So what you will have is f minus 2, and then the modulus will actually turn it into 2, right?
Yeah.
Which will say 5. Understand?
Yeah.
So what this message is saying is, remember function being like a mapping procedure, right? It means that if -2 shows up and asks you what value should it get mapped to, you are actually telling it, just take reference from your positive counterpart will do. And then the positive counterpart say, I'm going to 5. Hence, this guy, if you were to plot it out, -2 should go to 5. And if you do it for all the negative x values, they will mirror their positive counterpart as a result.
Oh, okay, yeah.
Understand? So somewhere out there, this is like -2, 5.
Okay.
Hence, it's a copy and reflect situation. It's not a cut and paste situation.
Okay.
Okay, because the negative counterpart guys are told to take reference from the positive counterpart. Okay, on the x values. Okay.
Yeah.
Okay, so that's for the simpler looking transformation. Okay. What about the second one then? This one? Who gets affected and how are they affected now?
Okay, so it's the first one. So only the negative x's are affected, and then all of the x's are affected.
What do you mean? Okay, so
Right?
so at the end, yeah, okay. So at the end of the day, who gets affected then?
All of them?
Really? You sure?
Because I mean, okay, so this is 2 transformations. It's the first one that we just talked about, and then it's a reflection on the y-axis, right? Oh wait, but then it's a wait. How does that work? It's a symmetrical graph, right?
Okay. How is it going to be symmetrical about what and how then?
Okay, so if it's 2 transformations, it's the modulus and then it's the negative. You do the modulus first, right?
Okay, to answer your question, these 2 transformations are...
Oh, because you're applying transformations on the input, so it's opposite.
Okay, yes. So
okay.
So you are seeing it from a transformation perspective, huh? Okay.
Yeah.
Okay, that's something that I haven't thought of before, but okay, I agree with you now.
What other perspective would you see?
Okay, no. It's good. So we carry on this discussion first. So you are saying do this one first, right? Followed by do this one. Okay.
Yeah.
Okay. So to do this one is to reflect this blue graph around the y-axis, right? Then you will have a graph that is like this. Correct?
Yeah.
Then now, so that takes care of this guy. Then now if you want to do this guy, is to repeat what we just mentioned, right? So you will have something like this and this. Okay? Understand what's going on for this one?
Yeah.
Okay. So I agree with you. And this is something that I haven't thought of before actually. Okay.
Wait, it's right?
Yeah, it's right. Okay.
Oh, okay. I thought you were gonna like explain my thought process all the way and then be like,
no.
This is why it's wrong at the end.
Right. So you are seeing it as a transformation, 2 transformations, and because transformations on the input, they have to be counterintuitive. So you do the negative first and modulus, okay?
Yeah.
Okay, good. Okay, if you were to see it from a function perspective, right, there is who gets affected, right? You will, based on the argument that we had in establishing the result for this one, you will see that it is the positive x values that get affected at the end of the day. For example, if x is equal to -2 again, if you send -2 into this expression, right, you will have f negative -2, right? Then modulus turns it into 2 first. So at the end of the day, you are still evaluating f -2, isn't it?
Yeah.
So the negative x values actually did not went through any change net.
Oh, yeah.
Understand? If they didn't went through any change on a net basis and they are still well defined and can be evaluated, right? So they should mimic what they were looking like in the original form. Okay. Conversely, it's actually the positive guys that get affected by this double transformation. Because if -2, if 2 shows up and asks you where does it get mapped to, right? If x is equal to 2, you're going to get f negative modulus of 2, which means that you
that's
get...
an easier way of thinking about it. Okay, yeah.
Really? Okay.
I mean, it's less steps.
So based on this argument, right, you're actually telling 2 to mirror their negative counterparts.
Yeah.
Understand? So it becomes a copy and paste situation, which is here again. Okay. So net is the same as what you just created for yourself, also, right?
Yeah.
Yeah. Okay. So
yeah.
On the what to do is actually summarized by these 3 points. Okay. So it's a case of copy and reflect. Understand? So
yeah.
Okay. So I personally have never thought of this from a transformation perspective, of course. So I always saw it as a function perspective on who gets affected. Okay, can?
Yeah.
Okay. I think it's because if you look at this as a single transformation, how are you going to analyze it from a transformation perspective? Because
yeah.
But when you couple with this, then it's a good thing. Okay. Okay. So this has to be coupled with the translation, reflection, and stretching that you have learned before. So again, the spirit stays the same. Modulus can be applied to both output or input, right? So when the form has part of a bigger picture, you have to decide whether to go with or go against the rules of algebra, which is something that you kind of did here already. Okay? So let's say if you have